Howdy, Abby. I was asked a question on number 20, and so I made this lovely video and then checked my answer in the back of the book, and I was wrong. So I'm not going to post that lovely video, and instead I'm going to talk through what I did wrong and then show you the correct way to do things. So on this one, they're saying that Sam and Marcus are standing on a level ground 100 meters apart. A large tree is due north of Marcus on the bearing 65 degrees from Sam. The top of the tree appears at an angle of elevation of 25 degrees to Sam and 15 degrees to Marcus. Find the height of the tree. Okay, so what I thought was, oh, they make a right triangle. When you look down from the, you can see you can see the tree, you can see Sam, you can see Marcus, and they make a nice little right triangle. And so I did all this lovely work where I found the distance. I called this S, that was the distance from Sam to the tree. I called this M, that's the distance from Marcus to the tree. I set up ratios, everything looked good. Then I came along and said, well, Sam to the tree, this is their distance, here's the height. And I found this and this when I did it the two different ways, but those are not the same value, and neither of them are correct. Okay, so this whole method was wrong, and what it dawned on me later is that Sam could be somewhere on this line, but it doesn't necessarily conclude that he has to be here where this makes a right angle right here. So just because he's on this, so let me clean that up a tiny bit. What we could find, oh, that was too much. What we could find is that Sam could be somewhere here. Oh, I had the wrong thing. My bad. Let me try again. Sam could be here, and this would still be. He would still have this 65 degree angle or 65 degree bearing to the tree, but he doesn't form a right triangle. Okay, so when I realized that sent me back to the drawing board, and I came back here and I redrew my picture, and I said, okay, so here's Sam, here's Marcus, here's the tree, and I drew in the north facing thing so that I could come up with this bearing, so that this angle was 65 and the other one is also 65 because we have parallel lines. Because those lines are parallel, those are alternate interior angles, and there we go. Well, so then, okay, all I had at that point was, this is going to get messy, I'm sorry. All I had at that point was the 100 meters between them and the 65 degrees, which was also right here. That's all I knew. So then I came over and said, well, we know that Marcus to the tree, we could call this length M, so it's Marcus's distance to the tree, and the height of the tree is H, and that angle of elevation is 15. So I was able to make an expression for the distance for Marcus. Okay, and so then I came along, I found that to be, I just used right triangle trig, and I dropped my pen. I used that right here. Then I did the same thing for Sam, using the fact that they had a 25 degree angle of elevation. Used tangent again. It came up with an equation here in terms of Sam's distance in terms of the height of the tree. So then that became this value, this length right here. Oh my, what a mess. Okay, so let me try and show you again what we're looking at. So now basically I have this triangle where I know that this is a 65 degree angle. I know that this is 100 meters, I think. This is h over tangent of 25, and this is h over tangent of 15. So once I knew that, this is gross, but I can use the law of cosine. So I came along and said, well, what happens here, I can think of this as, it's c squared equals a squared plus b squared minus 2ab cosine c. So I plugged in all the different parts, and this became a really gross equation that I was not about to solve by hand. So I went to my calculator and used the equation solver and typed all that in. And when I did, I got this 29.2 to 3 sig figs meters for the height of the tree. So that solved, and that matched the back of the book, so that made me happy. The other thing that I started working on that problem, but I haven't gotten it yet, so that's going to have to go in the next video. So hopefully that was helpful. I don't know if it makes you feel better or worse that I tried to use the right triangles, but doing it for both trees, or not both trees, it's the same tree, but finding the height in terms of both Sam and Marcus showed me that I was wrong. So then that sent me back to the drawing board, but hopefully that makes sense to you. All right, go practice.